Am I in the right place? Is this a Java meetup?
This is a
This-
.NET meetup.
I'm just kidding. Total joke there. I just wanted to raise some.
It's a better
Apples.
version, maybe.
All right. Well, we should be live. If we want to go ahead and mute everybody and get kicked off, we can do that.
Okay. Let's go ahead and get started. And I can't get the controls. Oh, there's controls. Sure, I guess. Okay, so everybody should be able to hear me. Welcome to the SLC.NET meetup for May. We're glad you can join us. Today we have Tim, who is our presenter. So it's Tim Collins speaking on real-time data analysis. Let's see, we will be doing speaker ratings. So you'll have the opportunity to fill out a form a little bit later for that. We would appreciate your feedback. So if you have anything good or useful to say, please share it with the intent to help us do better, both as hosts as well as give the opportunity for our presenter to learn from this presentation today. There is a YouTube channel which we are streaming live to today. In fact, if there happens to be more than 100 people who join, then at that point you would actually have to join via YouTube. So if you were to get kicked off, you can go to the YouTube channel and you'll be able to see it there. We do intend to monitor chat both in Zoom as well as on YouTube. So if you happen to have, or if that happens to work better for you, then ask questions via YouTube, that's fine as well. We will try to make sure that Tim is aware of all of the questions that are asked, since he'll be busy focusing on his presentation and content. But like I said, interact with us, put things in chat. So sponsors for today, we have Health Equity, Tech Systems, and DealerTrack as sponsors and hosts. So we are all kind of co-hosting and working together on this. So thank you. Okay, so with that, we have Tim Collins. So Collinson. So he's an architect within the Cloud and DevOps Transformations practice at Tech Systems Global Services. He brings experience and clarity to the process of defining, enabling, and sustaining value streams within his partner organizations. He works closely with partners to find their customers' needs and enable near and long-term visions for value streams. It is his passion to work together to define roadmaps to deliver those value streams. And today, we'll now turn the time over to him to learn more from him. So again, thank you all. And let's go ahead and get started with Tim's presentation.
Hello. Shall we get started then?
Yep.
Okay. When I share, you're going to stop sharing. So here it goes. All right. Hello, everybody, and welcome. I am Tim Collinson, and I will be speaking today on real-time data analysis using .NET, AWS Kinesis, Glue, and Athena, which are all AWS products, as well as probably a few other technologies that we're going to talk about, mostly from AWS, as well as a couple from Hadoop. So I am, as was said, I am Tim Collinson. I appreciate the intro, which I wrote myself. Thank you. And I work for Tech Systems Global Services. We are the services arm of Tech Systems, the sister company to the company that sponsors .NET User Group. And I am a practice architect in the DevOps Cloud practice. That I am an architect, and I am in a practice, and hence the name. It has nothing to do with practicing architecture. I don't actually practice any architecture on my clients or anything like that. I was told not to sell too much today, which is good since I'm not actually a salesperson. If they wanted that, they would have gotten an account manager on here, but they're not on. So I'm mostly just talk about technology. You can reach me at tcollinson@techsystems.com or at my LinkedIn, which is there on the screen. Now, before we get too deep into anything, I'd like to share some important links with you. These are some code samples, and these slides, you can go to a bit.ly link, the bit.ly.net UG-Kinesis, or you can go directly to this GitLab link. They go to the same place. They both go to GitLab. And from there, you'll be able to find these slides if you'd like to reference them. You'll also be able to get the .NET code that I'm going to be using in a little while. And I am going to be updating some of that code as well as some of the infrastructure as code section of this presentation over the next coming days and weeks. Feel free to check back there. You will notice that is at GitLab and not at GitHub. I prefer GitLab. That's my personal preference. So there you go. Go ahead and check that out now if you'd like. And then you can follow along. With that, we'll get started with what is AWS Kinesis. So we're going to be talking about a lot of AWS technologies today, and I'd like to start at the beginning with Kinesis. Kinesis is a streaming service, and it's actually a set of 4 different streaming services that AWS allows or has under the Kinesis umbrella. They have many other streaming services, including MSK, which is Kafka streaming, managed Kafka streaming. But Kinesis has 4 different products in its lineup. The first is Kinesis Video Streams. This is used for the capture and storage and processing of streaming media, videos, audio, things like that. For playback and analytics, there was a time where I worked on a project with a few people who have actually joined this meeting so far at Hewlett Packard, where we were doing some video and media streaming analytics, and we had to do this by hand because we didn't have a streaming technology yet, where we were processing petabytes worth of data coming in. This streaming media, Kinesis video streaming would have been the appropriate answer to that solution. You can take in huge amounts of data in video format and process that. There's Kinesis data streams. This is similar to the video streams, but this is for the capture of pure data. And there is also Kinesis data analytics. This gives actionable insights from streaming data in real time. And then finally, Kinesis Data Firehose, which is what we're going to be talking about quite a bit tonight. This is the one that I've chosen to display here. Obviously, if I wanted to show all of these, it would be numerous hours of demoing and things like that. This is for Firehose is for the collection, transformation, and loading of streaming data. I believe the next slide here, we're going to see some examples. So video streaming, again, camera, video, image data coming in real time, being stored and processed, and analytics become available in very real time, sub-second latency on each of the top 3. Kinesis Data Firehose does not have sub-second latency, and we're going to go over why that is and what that means for us as we go through the talk. But all the other top 3 have sub-second latency. They have auto scaling, and they have no infrastructure to manage. This is all done via a few lines of infrastructure as code or through the console. Data streaming, this is a competitor to Kafka. If you are using Kafka, you may want to take a peek at Kinesis data streams as a similar solution. Real-time production and consumption of those data flows. Kinesis Data Analytics, again, is built on top of data streams, and it makes analysis available extremely quickly. And at huge sums of data can be processed very quickly. We've seen at global services, we've seen terabytes of data per second processed in analytics available for various customers. Again, no infrastructure to manage on that. It's quite easy to scale up and scale down. And then again, Firehose, which is a little different than the other three. So as with most things, I like to start out with Kramer. This isn't actually Kramer. This is just the guy who plays Kramer in UHF, a movie from the 80s with Weird Al. And of course, he's about to shoot that fire hose at that small child's mouth. And that's what we're going to do as well with Kinesis Firehose. Let's move over to AWS. Apologize. We're going to, there we go. We're going to take a look at AWS and we're going to create a fire hose. So a fire hose allows you to accept data and then store that data extremely quickly.
I hope you die in your motherfucking sleep, bitch. I hope your heart stop on you in the middle of your rest, bitch.
Well, some people just don't like presentations that much. So, you know, it happens. Firehose, always a good time. So let's go and create a data firehose so that you can accept huge amounts of data in extremely quick. Somebody's drawing on the screen. That's kind of fun. I'm sure that there's admins that can solve all these problems. Perfect, even better. There we go. So, hey admins, let's take a break for a second while those admins figure this out.
Well, this is an adventure, isn't it?
It always is. It's okay.
Oh.
I think we got it.
Oh, perfect.
I think we blocked the appropriate party.
Oh, good. Thanks, Nicole. Nicole's like my favorite of all admins. Always solving all of my problems in life.
All right, everyone.
You guys are fantastic. Okay, let's go back to AWS, which is much less exciting than whatever that person was saying. A data firehose allows you to ingest a huge amount of data very, very quickly. Let's create one and then look at what that looks like. So as you can see, we already have one here, but that's less fun. So let's create a new one. To do that, you're going to just come in and create a delivery stream. We're going to name the delivery stream to, let's see, .NET demo Firehose 2. I've created a few of these today. Again, very simple to do, but there are a lot of options here. We're going to go over a couple of what those options are and then why you would use them. I'm going to keep most of them very default at the moment, but obviously if you would like to dive deeper, we can do that in questions, or you could try it yourself. A lot of this isn't all that expensive to try. You can actually get on and with your free tier usage, try out Kinesis Firehose right now and not go over your free tier usage on AWS. And if you did, sometimes it's very, very inexpensive to use. I will give a few spots for you to be concerned about price as we go forward, but this is certainly not going to be it. So you name your delivery stream. Next, you select a source, either direct put or other sources. This is what we're going to use today. You can also do a direct from another Kinesis data stream. So if you have a stream that is pushing data in, you can actually push that to a Firehose and allow that to do some processing on that data and then store it in an S3 bucket, which is what we're ultimately going to do. But today we're going to do direct puts. You can also do server-side encryption on all your data. That's very easy, very handy. You can do that using either AWS-owned CMKs or your own personal CMKs that you bring. We're going to go ahead and not do that. The next part, this just shows you how to use that. After you've named it, decided where it's going to come from, you're given the option to transform the source records with AWS Lambda. This is extremely powerful. Imagine for a moment that you're getting data coming in from all sorts of locations. And that's the point of this. You're getting data coming in from maybe application logs from all sorts of different applications, from devices on an IoT basis, from third parties. I've seen people who are processing medical transactions with this, coming in from a repository of medical transactions, coming from insurance companies. And you need to transform that data. You need to do something with that data before you store it. What this allows is for you to take every record that comes through your Firehose and send it to an AWS Lambda. If you're not familiar with what an AWS Lambda is, a Lambda is simply a serverless compute that turns your screen red. It's cute. A serverless compute which allows you to run some arbitrary code against an input and push out an output. You could do these in .NET. You can pick, I believe there are a dozen different existing languages that AWS supports, including .NET. You could also use any custom language that you'd like by just creating a container for it to run in. So it's very simple. We're not going to pre-process our data coming in on this Firehose today, but if you want to, you could simply do that and push it to a Lambda function. Very simple. You can also convert a record using Glue. We are going to do that. However, I'm going to do that in a slightly different way later in the presentation. We're going to, this will accept a JSON object and do some conversion on it using Glue. Again, we'll get to that in a moment, what that looks like and why you would want to do that. But for now, let's just accept a JSON object and push it in. Next, we're going to do a source destination. This is where do you want to put it? You get a couple of options. S3, Redshift, which is another good data source. You could put it directly into your Elasticsearch or Splunk. Today, we're going to go ahead and use S3, and we're going to create a new bucket. So, and that bucket name is going to be .NET UG demo bucket 2. And we're going to go ahead and throw that in Oregon, but it could be anywhere. Remember that a bucket name must be unique across all buckets in all of S3. So you are going to want some very specific bucket naming. Let's hope that nobody has that bucket. They don't. That's great. It would have just thrown an error. And so again, this Firehose is going to take objects, whatever objects we send to it, and it's going to pass it through to an S3 destination. When we're doing that, we can actually put a prefix at the front of that object. The default is, as you can see, year, month, day, and hour. We're going to keep that prefix. However, you could actually give your own prefix. If there are errors, it will also put those errors into a bucket, and you can prefix those errors, which would be handy for other things later. Now, as I mentioned earlier on, Kinesis video streaming, data streaming, and real-time analytics are all in real time. Firehose is not quite real time. Firehose has two buffer conditions. One is the size, and you could go anywhere from 1 to 128 meg. We're going to go ahead and drop that down to a single meg. And what this means is that when it gets a single meg of data, it will create the file and drop it into S3 bucket. You could also do it by interval. In fact, you have to do it by both. The lowest interval is 60 seconds. So if you get less than 1 meg of data, it will create a file every 60 seconds. If it gets no data, it creates nothing, quite obviously. But you have to hit one of these two gates. I'll show you this in real time in a moment. You can also do some encryption. We're not going to do that today, but they give you some encryption and some compression options for your data coming in. Error logging is logged to CloudWatch as well. Always handy. You can tag your resources, which is another handy thing. This is great for cost management and organizational management. Today, we're going to leave those blank. We don't need them here. And then you need to give this a role. So we're going to go ahead and give it an AIM role. It's going to be nice to us and give us a default, which is very handy. And you can view that policy document right here, which gives us certain Glue, S3, and Kinesis permissions. You're going to want to get good at this. We're going to talk about AIM permissions in a little bit. Once you're all done, it gives us the option to double check, and that's it. It sounds like a lot, but it really wasn't. The defaults are fantastic. The defaults will allow you to generally very quickly get a Firehose ready so that you can accept data from any given source. We're going to go ahead and create that delivery stream. And it's going to go through a create process, which is very quick. And while it's doing that, we're going to come over here and take a look at some code. I have created a little bit of code as an example of how this works. This is using the Kinesis Firehose AWS library. It's going to create a JSON. We have a class that defines a JSON object. We are using the really fantastic Newtonsoft JSON converter to take that and serialize that as a JSON object. We are then going to dump that to a Firehose. So, and all of this code is available currently at the GitLab location that I showed earlier. And at the end, I'll make sure that you have that bit.ly link one more time so that you can get to that code if you'd like. As you can see, what this does is it just creates some random data. Mostly we're just throwing a random number at the end of a couple of strings. We're grabbing some date times. We're taking a lorem ipsum and just grabbing a substring of it at random. And we're going to throw some fake data into our Firehose. Then we're going to just loop.
Tim,
yes.
Your text is very small. It's unreadable on YouTube. You might maybe zoom in just a little bit for us. Thank you.
Whoa, that might be. How about that?
Looks great.
A little better. Okay, sorry. So once again, real quick, just creates an object with some random data and serializes it. Now we're going to take this and put it to a Kinesis stream, the one that we just created. So the stream name is there. You have to have permissions to the account. Those permissions are already set up for me. I'm not going to show you because obviously there are some people watching that are less scrupulous than others. It is very easy to set up AWS permissions on your application. The documentation is readily available. I would do it the standard way that it says to do so, and do not check your permissions into your repo. Create an Amazon Kinesis Firehose client. And then what we're going to do is we're going to loop through and make some random data and push it in. So right here, this allows us to put a record batch in asynchronously. AWS Kinesis Firehose allows you to batch in 500 records in a single batch. They also have a similar single record method, which instead of taking a list of records, it just takes a single record. But to batch in enough data very, very quickly for this demo, we want to just quickly toss all of this in. So we're going to toss in 20 sets of 500 records and watch that go. It's a little console app. We're just going to quickly run it. I want to show, as you can see, our Firehose is now ready. It is active. And let's go into S3 and take a look at the bucket that we created, which should be demo 2. You'll notice that there's no data in our bucket because we have not pushed any in. We will run our console application. It will dump a bit of data. Now, you'll remember that our Kinesis Firehose had a rule. It said, I have to see either 1 meg of data or 60 seconds worth of data. Well, this is going to create, I believe in my test, it's going to create between 4 and 5 megs of data. So fairly quickly, we should start to see data flowing in to this bucket. And you can also monitor it using the AWS console monitoring. But by now, we should start to see some data ingestion. There it is. So there's some of our data. Let's go drill in. Remember that it gave a prefix of the year, the month, the day, and the hour. And there's our first file. And there's our second file. And it's just going to keep streaming that in. I want to show you what these files look like. So we're going to go ahead and open one. We'll open it in Visual Studio Code. And here's our data. We'll shrink that down for a second. And you can see it gives you numerous JSON objects. They are not separated. They're actually separated by a carriage return on purpose because each one of these is a separate JSON object. They do have things like current time. So they have date timestamps. They have numbers. They have, here's an array within it. Very simple. So, and by this point, I would imagine that everything is now in. Yep.
Does that contain only your properties, or is there some that are artificial that are automatically added?
This only puts in the properties that I posted. That's a great question. So name, type, current time. This does not add anything at all to the documents that are coming in. All it does, and it also, you'll notice that we put it in batches of 500. This is not a 500 batch. This is far more than 500. Let's just go to the bottom. So this is what, 3,000? 2,388. So it stopped because it hit that 1 meg limit. And so it wrote it. So it processes those, it splits them apart, and it throws them in here.
And presumably it's not a fixed 1 meg limit. It's just, okay, now this is the next record. I'm now over that 1 meg. So now I'll batch it up.
Now I will batch that up. And so this is actually now finished. So we had 4 that hit the 1 meg limit. And then we had another one that was at 196K. And after 60 seconds of waiting, it wrote the file. So that's all the data. That's what our little command line tool put in for us successfully. And by the way, this does not have to be in JSON. You can throw anything at this. You can throw in CSV data. You can throw in XML. You can throw in proprietary formats that somebody made up. We've seen all sorts of data come in here. It doesn't do a lot of processing on it. It just puts a carriage return after each object and slams it into an S3 bucket for you. We're going to get to the transformation and in a minute, the T and the L part of the ETL process in this. So that's our Firehose. It accepts things. We've done quite a bit of data. It's very easy. You can accept data nearly instantaneously. Let's go back to our slides for a second. So it's great for receiving huge amounts of data and storing it quickly and effectively. It's always going to go to the same place. One thing I do like to point out is if you have data that is in disparate formats, if you have somebody that is sending you data, say credit card data, and that data is transactional data, and that data is coming in as CSV, and then another processor is giving it to you in JSON and one in XML, you may want to create different Firehoses for that and put them into different folders because you're going to transform them later in different ways. The other option would be take them all into a single Firehose and use that Lambda property to appropriately start transforming that data. It does have powerful transformation abilities. We're going to show you that. This is extremely low cost. You're basically paying only for the ingestion and the storage in S3. The ingestion cost is a few cents per gig, and it goes down the more you're taking in there. And it's an extremely low barrier of entry. I have yet to find a client that has tried this who did not very quickly get up and running with a Firehose. My daughter asked a lot to be able to add memes to my presentation, so I let her. And this one was highly effective. This is a note on S3's and bucket permissions. This is a walrus, and he has a bucket, and then somebody is stealing his bucket. It's probably my favorite meme for this presentation. I think AWS should hire this walrus. He loves buckets. Be very, very careful with your bucket permissions. If you make your buckets public, people will grab that data and it will become public. Spend the time going through IAM permissions, bucket permissions, and roles and policies is well outside of this topic. And we could spend days on making sure you understood all the finer points of AIM permissions. You should do that before you get your sensitive customer data or your sensitive business data into AWS S3. It is not that scary. I am glad to answer questions about it. If you have them, feel free to email me or reach out on LinkedIn. And there are many others who are there to help. AWS is a great resource, and their customer support will help you as well. But be very careful, because you do not want to be like the walrus and have your bucket stolen. So be very careful. Let's move on to the T&L part of the ETL. What is AWS Glue? AWS Glue is a fully managed ETL tool, which stands for extract, transform, and load. And this is going to prepare our data for analysis and analytics. AWS Glue allows us to take those documents that we have put into our S3 bucket, which is now essentially a data lake, and get them prepared into a database and ready for consumption. We can also transform them. I'm going to show us a little bit about transforming with Parquet. And then I'm going to prepare to use SQL on the back end to grab that data. So let's go ahead and create a Glue database. Coming back over here, we're going to come into Glue. This is AWS Glue. We have a few databases in here, but we've just added some data into our S3 bucket. So let's create a new database, and we're going to call this the .NET UG. Database, demo database. And that is how simple that is. We are now going to create some tables out of our data, and we're going to use a Glue crawler to do this. We're going to go ahead and name this the .NET UG crawler demo. There are numerous options that you can use. Again, tags and descriptions and security to allow you only the appropriate people to access this, as well as to handle data encryption while you're running your Glue crawler. But this is essentially going to crawl through all your data and attempt to make a schema of that. So we're going to go ahead and do a data store. That data store is an S3 bucket. Guess which one it is? This is going to be our S3 bucket that we just created, the demo2 bucket. You can also exclude patterns. So if you don't care about some of the data as you're creating your tables, and you can think of these tables quite like you think of SQL tables, but what this does is it's taking a look at the data that you already have and suggesting what your table should look like. If you have data that you've added that you want to exclude, you can put that there. By path, you can add multiple data stores. Today, we're not going to do that. You do need an AIM role for this. We're going to go ahead and choose an existing role because we have one that works. Again, remember the walrus. Don't let people steal your data. come to learn about AIM roles. Glue crawlers use compute on AWS, and all you're paying for in the crawling process is the amount of compute that you are using to figure out what your structure should be. So you can run your crawler in various ways, all the way down to every 5 minutes on your data to monthly, weekly, days, hours, or on demand. I'm going to run on demand today. And I'm going to remind you later that this is one of the areas where you can spend a lot of money accidentally. If you happen to set up a custom and it uses cron expressions, and you run this every 5 minutes, you're going to be very sad because you're going to run up an AWS bill extremely fast. If you run it on demand once, you're going to pay almost nothing. We're going to go ahead and choose a table that we want to put this into. You can add a prefix name for your tables inside of your database. We're not going to do that. We don't need to. It will create it for us. And then there are some other schema options. Most of these are for more complex use cases than what we're getting to today. And then you review and you finish. Once that's finished, we can go ahead and run the crawler. I'm going to run this crawler, but it does take a little bit of time. This is why this isn't real time, but necessarily, but near real time data analysis. What I have done earlier today was I would like to show you a different. Yes, this was another example that I uploaded. This was 21 documents, or about 21 megs worth of data that I uploaded earlier. This data looks exactly like the other data. It's just a little more of it. And in Glue, I created a database for this, which I have already crawled. So the output of the crawler that we just created would come into a database much like this. And sometimes the AWS console likes to not show things. And it will create a table. So it created a Firehose test bucket table. You can name this differently if you want. It is pointing at the location of our bucket. So it's saying this table points at this data. We've noticed that this data is JSON data. Let's see what the structure is. And you can see the structure. It has a name, it has a type, it has some time stamps. According to JSON, these are all strings. It has some numbers, which are ints. It has some things that are in an array, and that array is an array of string elements. And it has some lorem and some strings. Great. So it has now figured that out. And we now understand our data, and we can now do some conversion of it. Let's go ahead and do a transform and load operation, which we can do in the ETL section of Glue. We'll go back and double check that our crawler isn't done. Oh, yeah, actually our first crawler did finish. So if we come back to our demo table, this is the table that we just created, and it figured it out. It's pretty good at this. Now let's say that we want to transform this data. There are a couple of reasons why you're going to want to transform it. Sorry, we're going to go to not a workflow, but a job. And we're going to do a Parquet transformer. Let's go back for a moment to our slides. So what is Parquet? It is not butter. I love this because every time I say Parquet, somebody remembers the old Parquet commercials. They're great. That's not butter, by the way. That's margarine, but whatever. It is not flooring. It is Apache Parquet. Apache Parquet is a column-oriented data storage format, and it's part of the Apache Hadoop ecosystem. Apache Hadoop is used for a lot of large data platforms. It is a great way of storing data. And you're going to want to think about using that if you're storing a large amount of data. Let me show you why. Our data here from earlier today is about 21 or so megs. Let's go in and take a peek at our metrics. It is, yeah, so it's about, 20.9 megs. We have over here another bucket that I created using the ETL process that I'm about to show you. There we go. And in it, we have Parquet files. You'll notice that these Parquet files, there are still 21 of them, and each of the Parquet files are much, much smaller. Parquet is a much more compact format, but as you can, and you can see that we've shrunk that 20.9 megs down to 4.5 megs. So a lot of savings on your data. If you're storing terabytes per day, you may want to take it in a JSON format or a CSV format or an XML format and convert that and then store these off to something like a Glacier so that you're saving money on your storage. So let's create a Parquet transformer. We'll just call this Parquet demo transformer. Guess what? As with anything, it needs an AIM role. This is a Spark product. So we're going to go ahead and use Spark. I would just keep the defaults when doing any sort of a formatter. There are some advanced properties, most of which are outside of the scope of what you'd want to talk about and are for more advanced usage. One of those, though, that you should take a look at is, again, that security format. And this is the maximum capacity. This tells us how much glue you're going to be using and how much cost you could potentially have. This is where your cost savings can come in. If you have a lot of data to transform at any given time, you are going to want to watch and see how much capacity and concurrency you have. If you get that too high, you will process your data a lot faster, but you'll also pay for it. So be very careful there. There are some catalog options, most of which we'll skip past. You can then take a data source. We're going to take the source of our data that we first created just a moment ago. This is the data we just pushed in. We're going to go ahead and change the schema as we are passing that in. And we're going to push this into a Parquet output database. This is the powerful part of the Glue ETL process. You'll see that over here, this is what we found using our Glue crawler. And this is what we can turn it into, but it doesn't have to be that. If, for example, you want your current time to be a timestamp, you can actually change your data types, which should come up. Oh, the demo gods are not with us today, but nevertheless, you should be able to change your data types. Strange. You can remove columns. Let's see. Oh, that works. So if you were to decide that you don't need a less important number, you can get rid of that. You can also get rid of other things. And so what this is doing is this is taking a timestamp string, turning it into a date time. It's removing columns, and it's preparing that data to go into a format that you can then consume. And if we save that job, you can see that this is actually written in Python, but it gives you what you need. So a Glue transformer is always written in Python and run via Spark process, but it's fairly simple to read and understand if you ever needed to change this. You can also do all of this via infrastructure as code using something like CloudFormation or Terraform, and it's very simple. You could run this, but it is actually a very long process to run. Usually, it could take upwards of, for a data set like ours, upward of a few minutes for it to get a Glue processor. And then it takes actually only a few seconds to run on this data set, but we don't want to wait for it. You can actually run your own Glue processor on AWS, but then you'll be paying for that as well. You'll run that as an EC2, and you can use that instead of AWS's managed version, and then you'll get much faster processing time, but you'll pay for that bit. This was my Parquet formatter, which I spelled wrong a little earlier today. This is what created these Parquet files for us here. And as you can see, it succeeded, and it had a 35-second runtime. It charged for a minute of execution time. So, and at that point, it creates Parquet data, which you can then come into a database and create a similar Glue database with Parquet data. You can now see that our data that was strings has date times. We've gotten rid of an unimportant number, and it's transformed that data, and it understands what objects are in it. So this is Glue. Very powerful tool for transforming data. We'd like to just make sure that you understand that you can have too much Glue. If you have, again, a crawler or an ETL job that are running pretty constantly, you have to watch out for your costs because it will run. If you tell it to run every 5 minutes and the data hasn't changed, it will run every 5 minutes. Generally, we help people to turn on Glue only when data changes and only on certain schedules when data changes so that they don't pay too much. If you want to try this out for yourself, the things that I just showed you in AWS cost pennies. It's nothing to run it on demand once or twice. So now, here we are. We have ingested our JSON data or other data. We have pushed it in through a Firehose. We have created a database. We have figured out our table structure. We have transformed our data into Parquet with Glue so that it is cheaper and smaller to manage. How do we query it? Well, there's a lot of options here. You could go down a Redshift path. You could hook all this up to Tableau. You can get to that data in any number of ways, but today we're going to use Athena. AWS Athena is a querying tool that I love because it allows you to query and analyze your S3 bucket data using standard SQL. So if you understand how to write a SQL statement, you now understand how to grab the data that we just put in. And it has out of the box Glue database support. So let's go ahead and go into Athena. This is AWS's Athena, and it generally takes you straight into a query editor. Now, right here, you can see our data sources. We're going to go ahead and look at some AWS data catalogs. And you remember, over here in Glue, we have these databases. Here they all are. Over here, we have the same databases. Here they all are. This is the demo database that we just created. I'm going to take a look at this Parquet database. And in that Parquet database, we have a table. And that table has data. So let's go ahead and take a peek at that data. We're going to go ahead and write some SQL. So let's just select the very first. Let's just select the very first record and take a peek at what it looks like. So that's going to go ahead and run. And there's our first record. And it looks like just regular old SQL. Even though this is in Parquet format, which is a column-oriented data storage structure, Athena has changed it and made it, again, something that you're more used to, a row-based. Let's do a slightly more complex query. Let's go ahead and let's group that data by the important number. And let's order the results. Let's see what the count is. The highest count important number. So we're going to take important number. That's one of our columns right here. And we're going to see what important numbers we got and what the group by count of those was. And there we go. And actually, we're going to be, let's do this as count. So this should feel extremely familiar to anybody who has ever written a simple SQL statement. We're going to name the column as count. One of the things that this is doing, though, is this is reaching out to some processor to run. So the query itself runs very, very quickly, but sometimes you need a processor to become available. So it looks like Import number 4, I had a count of there are 1,278 rows with import number 4, and that is our most important number. You could certainly do other queries very quickly on this data or any data. So the power here is that now we can run these queries just as you normally would with any sort of SQL. What we would like to do is do that in .NET. Through AWS SDK, you can actually do this. They just updated it, and right before I started the presentation, I did a bad thing and I updated the code and it stopped working inside the code. But if you follow the GitLab link and watch over the next couple of days, I'll get that fixed and show you. But essentially, it's a simple set of queries that can then be put into a .NET object. It's not a terribly complex demo. And you can use this inside of your actual applications very, very quickly, the same way that we did pushed data to a Kinesis stream. Obviously, extremely easy to set up and quick. You can also have saved queries. This is great for, this is not something that I would suggest as being your end-all be-all data backend. I think when it comes to .NET, SQL Server is extremely good. And as relational databases go, you should continue to use that for your relational data needs. What this is good for is if you have a ton of data coming in different formats and you need to get it all into a single format and then be able to query it in a language that you understand natively or that your engineers at your company understand already. SQL is pretty ubiquitous, and we all know it fairly well. So you don't need to train people on Tableau or how Redshift works. You can just quickly use your SQL querying skills against data that has already been transformed and loaded. So what is my next thing? It's question Tim. Question Tim, question time. So before I go into the questions very quickly, that is the end, by the way. If you have any questions that you don't get to ask me, feel free to reach out on LinkedIn. Feel free to email me at tcollinson@techsystems.com, or you can get a hold of me via GitLab through that bit.ly link. So this bit.ly link will take you to these slides, to the GitLab with the code and other things. And so now, while that's up, I will take any questions that people may have, which I will do by going to.
So one quick comment, I just put, once again, the link to presenter feedback in the chat. So please go there, follow that link. Hopefully it won't pick up the period at the end. If the link doesn't work, it's because it did pick up the period at the end. And then provide us some feedback, both on the hosting today, as well as feedback for the presenter. So with that, we'll open it up to questions.
Hey, Tim, can you hear me?
Yes.
Good. On the Athena, I recognize that the sources were from 3 of the Glue databases. Athena says that it can also search directly from S3. So is it able to actually go to S3 as a source rather than having to wait for Glue to transform it?
It can. So yes, you can actually go directly if you, it needs to be in a format that it can understand. That's why you generally do put it through some sort of a Glue process first. But the Glue process does not have to require a crawler like we did or an ETL process like we did. You can actually define the table in infrastructure as code extremely quickly. And as long as your data is in some format in S3, then Athena can understand that. It does need to know something about your data, and generally it's Glue that allows you to do that. There are a couple other ways to do it, but.
So when your Glue process runs, does it run on all of your data every time, or So it's scheduled to start off where it left off. Was that configurable? And
It is. So yes, it can run on. So if when you're talking about an ETL job, it can be configured to run off of just the data that it hasn't already transformed, or all data drop and reload. Generally, obviously, people like to only run the data that they've already haven't already seen or haven't already converted. And definitely it can stop, or it could start where it left off. Some people will, as part of that, also move the data off into long-term storage. Again, a lot of the ETL jobs, well, they're fantastic for a number of reasons. You can get CSVs into the correct format to ingest. You can save in space. You could do all sorts of nice things as part of that ETL job. But one of them is certainly to reduce space and move those off to S3. In that case, your data is always the next set, which is pretty handy. But it is smart enough to know where the last set was.
Mm-hmm.
what other good questions do we have?
Or even bad questions.
Oh, we're not going to judge. We just want questions.
Somebody cannot unmute himself. D. Curtis, if you write your questions, I think we're having some problem with unmuting certain people. And we don't distrust you, but we would like you to write your questions.
Okay, so I
think I'm
unmuted
back
him.
now.
There.
Okay, I had the previous question about the glue.
Great.
So if you can use say Athena, which allows you to use SQL, very easy to pull information directly from S3. My first thought is to try to get rid of the middleman, being Glue. If you say you had 3 sources that you're pulling all information in using Amazon Kinesis, could you format your 3 sources of data in such a fashion that you wouldn't have to use Glue and get it away from being a thing you have to use?
You do need to still allow, you need Athena to essentially understand what the data looks like. We use Glue to do that. You don't have to do any transformation, and you don't have to do any crawling. So let me see if I can find an example on, if you haven't used HashiCorp Terraform, this is a fantastic infrastructure as code solution. And they have a Glue catalog table. So you can also do this using CloudFormation, or you can actually do this in the console. It's just kind of clunky, and I don't particularly love it. I much prefer something like Terraform or CloudFormation for something like this. And I can actually add an example of this into the repo over the next couple of days. But essentially what you could do is define what the columns are and say, I don't want you to crawl, and I don't want you to do an ETL. I'm going to tell you what the columns are going to look like. And as long as you then put the columns into that format, or somehow transform it into Parquet in that format, it can also be, by the way, JSON. It can be CSV, like I said. It could be XML, whatever. But if you can get your data into that and then just let Glue know that that's what it is, Glue will run nothing. You will have no cost. You do not have to run a process at all. And then you could start using Athena right away. But you do have to have some sort of a definition around the data. If you'd like to see, this was the demo that we put up during this talk, and we can actually query this in much the same way instantly. And we did not do any sort of a transformation. This is still in JSON format. So, but you can absolutely take out that middleman.
No, that's cool. That's helpful. Yeah, those infrastructure tools are super nice. CloudWatch, Terraform, yeah, I use those as well. As I'm sure many does, and if you don't, please do. But that's really good to know. Another question that I have is, you mentioned that you this demo was for specifically Firehose, and how there's 3 other services under Kinesis that are live or real time. Analytics versus Firehose, I suppose, is the question.
Sure,
Why?
absolutely.
That's the question. Yeah.
So I think analytics is an entirely different use case. So and they have some great demos on AWS for this, but you can take some basic analytics and even some very complex analytics directly from the data, much like CloudWatch does with your real-time analytics of your logging. And in fact, that's what CloudWatch is more or less built on top of is Kinesis Analytics. So it's just a slightly different use case. This is more for consumption of data and storage of that data. If you were to look at something like data stream, you would need a producer of the data, so something that sends in the data, and then and a consumer of that data, and it just streams it, and it sits on that stream for a while, available for consumers. So if you had multiple consumers that needed different parts of that data, that's when you would use a data consumer instead of a Firehose. Firehose dumps it to S3 and creates a data lake.
Gotcha. So Firehose's main goal is to store your data, whereas the other ones are meant to analyze or to do something else with it.
Or allow a stream of that data for an application purpose. Yep, exactly.
Okay, right on.
So if you had a bunch of processes, when I think of data stream, for example, analytics, I think of CloudWatch. CloudWatch is a great example of real-time analytics in AWS. If you aren't familiar with it, go out and take a peek at it. It takes real-time data and from your application logs and produces it for you in a nice dashboard, or maybe a slightly less nice dashboard, but it's okay. When I think of Kinesis data streams, not Firehose streams, but data streams, I think of things like if you have IoT devices that are pushing out huge amounts of data. Imagine Amazon Alexa actually uses this quite a bit, where they're dumping a bunch of data from the device into a stream, and that's the producer. The consumers are a whole bunch of AWS Lambdas that are just peeking at that stream and seeing if something interesting has come up that it wants to process. So maybe you have one that just does timestamp processing and dumps them so that I don't know why, it's probably a bad example. But another one does some sort of other analysis on the data. It can just constantly be looking at that stream of data and taking out only the data that it needs. And other consumers can also get that other data out of those streams. And so it allows for a very interesting data movement and data bus for your small serverless microservice applications. And video is the same way, but with video and media. So.
Yeah, of course. I have more questions, but I don't want to stall anybody else from asking questions.
I'm glad one person said some questions. That's good. Keep on going. Why not?
I have a question.
Oh.
What the DevOps side of me wants to know, like, how easy is it to manage a system like this long term?
That's a great question. I have seen people who are managing this. The largest implementation of this was running about 100 million transactions an hour, or inputs per hour, numerous tens of terabytes per day over a number of months, and they're doing it in the medical space. I find it fairly easy. I think people can certainly overcomplicate the process. They, for example, try to throw everything into a single Firehose and then try to do stuff with it to get it all into the same process or into the same format. I think you should be very judicious with the number of Firehoses you have. You can have too many, but you can also have too few. I have shown most of this in the console today. I think that's the inappropriate way to do most of this. But if I were to show it to you purely in code like this, it would be an extremely boring talk. So it may have already been an extremely boring doc, but it would be even worse if it were just a bunch of JSON documents that dumped into AWS. But you should generally keep all of your infrastructure as code. And from there, it's fairly easy to manage. Most people, it turns out, have only a couple of types of data that they're pushing in. They need to, maybe they have a lot of input streams, but ultimately they want it formatted in a few ways and then stored in those ways. And so understanding that architecture can help you to not overcomplicate your process. And again, I would absolutely tell anybody who is using AWS or Azure, although they don't have this, but take a look at HashiCorp's Terraform for your infrastructure as code. It makes things much more simple. So. Other questions?
So something that's a little fascinating to me is the glue. Not only does it just transform data, it stores it as a database. What are the costs to it actually storing it? Because I know it's not like an RDS or like a NoSQL or SQL database. Like, that's interesting.
So it actually doesn't. They don't charge. So it does keep a bit of metadata. And if we take a look over in our S3 buckets, we can see where it's keeping some Glue temporary files and some Glue scripts for you. And that's essentially the only charge over the long term, is whatever the cost of these are. Temporary gets dumped as soon as it's done. I think the Glue scripts holds a couple of things, but not a lot. So you can see a couple of K. It's extremely, extremely inexpensive from that standpoint with Glue. The database itself, remember that the tables and the database are essentially just the data that is in S3. So your tables are this. This is the table data. So you're already storing that in S3, and that's your cost. So if you are not running a crawler, if you are not running an ETL job, and you're just keeping some AWS databases out here, it's extremely inexpensive from a Glue standpoint.
Okay, because when I see database, it's like, so most of the storage cost is just from S3, and then Glue is just saying database, as in it's just, this is the information that I gathered or transformed for you so that you can see it. I think you mentioned temporary files where you can temporarily have it show up and disappear over periods of time if you wanted to, I imagine. Okay, so there's not deep costs when it comes to that.
Yes, well, where the deep costs come in, and my big warning again for anybody who listens is if you run those crawlers too often, or if you run those ETL jobs, you can run ETL jobs with machine learning levels of transformation and machine learning levels of hardware. You can get high-end, very memory optimized hardware running those. And if you run those too often, you will run up cost very, very, very quickly. And probably for not much value, especially as you're testing. So be careful and watch your cost management within AWS. I don't want anyone to walk away and go, oh, I kept a 5-minute job running for the last month and now I have a $20,000 bill. So be very careful.
Does Glue pull data from other sources rather than just S3?
Glue can create a number of different sources. So it can crawl different sources. It can also ETL different different data sources.
Okay, like it can crawl your RDS database?
Generally, no. It's mostly flat file. It's things that Glue, there's a lot of documents.
Yeah, because I wouldn't think it would need it to go through an RDS database as much.
Yeah.
You should already have it formatted in the schema that you want.
You can essentially set up data sources that aren't in S3, but it's still mostly flat files that it's actually crawling.
Okay.
So I had a question about Glue compared to like Talend or Matillion. Cost-wise, do you know how they compare?
I don't have it in front of me. Again, with Glue, what your cost is only in the ETL part and only when it's actually running, and you can get very fine-grained on how much cost there is. Again, most people screw it up when they run it too often on data that's already been transformed and they're just not paying attention to how that works. I'm not familiar with the other technologies that you mentioned for ETL, which is what I assume is what it does.
Yeah, they're ETL tools.
But if they are, I mean, certainly you can run up those costs as well, or not, depending on how you're running them. If you were to run them in an EC2 or in a job format in a Lambda, I'm sure you could get the cost similar or even lower. But ETL, but from an ETL standpoint, Glue is nice because it's a managed product that's right there. So,
Okay, thanks.
Really enjoyed your presentation today, man. Thank you.
well, thank you. Appreciate it. If there are no other questions, which I don't mind answering at all, and again, let me throw up my last slide there so that you can see. If you do have any questions, feel free to reach out to me. I am available, and I'm glad to answer any of them. If you would like to get into more of the security side and the permission side in AIM or in the cost management, feel free to reach out to me. I can at least give you the resources on how to get that taken care of. So with that, I'll turn some time back over to our moderators.
Thank you very much, Tim. I'm going to go ahead and present screen here. Oops. Okay, so again, I already shared the link. You can see it right here, but we do appreciate speaker feedback and feedback on how we've done at hosting this. So please share your information. So if you do not already know, we do have a Slack channel, not just for us as a group, but for the Utah.NET community. There is a link down here for those who do not already have a membership in that particular Slack group. So you can click on that and join us. Otherwise, it's utah.net. .slack.com. You can also get to it from our website at slcnet.tech. So if you go there, you'll get a link to any of those. We are always looking for presentation proposals. So if you would go to our presentation proposals link there, tinyurl.com/slcnet, and sign up, right, or submit a proposal for something that you find that's interesting. That is somehow related to .NET, then we would love to take a look and review. It can be brief, it can be in depth, and depending on what kind of questions we have, we might reach back out to you and just have a conversation about that. But we do welcome those proposals. Let's see, our next meetup, Thursday, June 11th, we have so if assuming we are still online and using the online format, presentation time will probably be 5:30 again. I think we can pretty much plan on that. But we are looking for presenters. We have some discussions going on, but I don't know that it's solidified or solid yet, hence the TBD. So please get your presentation proposals in so that maybe you can be the next person to go. So that is all that we have for today. We thank you for all of your participation. Thank Tim for his time to prepare and all of the content and knowledge that he's shared with us today. And we hope to see you next time. So one last comment, and that is, if you haven't already, subscribe to our YouTube channel, because if we get to 100 subscribers, then we can have a direct link that will make it easier for all of us in the future. So there was a link earlier to that, but we would love to have you subscribe. You can easily find us if you just look up SLCNet user group in YouTube. So thank you and enjoy the rest of your evening.
Thanks, everyone.
Thanks.
Thanks, everybody. Appreciate it.
Thank you.
Bye, y'all.